to create a new project and continue working with it. We need to add photos to the project. This can be done by selecting the folder containing the photos or dragging files into this window. Note that you can either specify an entire folder or select all files minus unnecessary ones. After selecting a directory, a menu appears in which we can enter a project name and select a coordinate system. The software interface then opens. It displays the work area, content, status bar, current tasks, and a preview. Now we'll add the coordinates of our points from a separate file. Please note that you need to select a different coordinate system and specify the order of markers. After that, we need to specify the destination for our data. Note that on your screen, you can now see markers at the locations where the photos were taken. Next, we need to clarify some data regarding the camera parameters. These parameters are loaded automatically from the metadata, but we can make any necessary changes. Note that because of the additional data file, we already have a georeference location relative to the selected coordinate system. Now you can see in the settings and attributes of the new menu which processes, which types, and which settings we can change. We can also use the View menu to show or hide certain data. This can also be done from the Content menu. Next, to begin working with our photos, go to the Processes menu and select the first step we need: Calibration. Please note that in addition to the basic options, there are also additional options, and each of these parameters can be found in the user manual and product instructions. After selecting the required parameters, we click the Start button and wait for the photo alignment process. Notice below that we see the progress the image alignment status. When using various photo software and image alignment, this is one of the most important steps that allows you to achieve high-quality results. Therefore, when aligning photos, don't skimp on your system's resources and choose high processing quality. Note that we have already received aligned photos. They differ from our initial methods. Next, we need to build a dense point cloud. Note that in addition to the basic settings, there are also additional options that will help you adjust your settings for a higher quality result. Generating a dense point cloud is a labor-intensive and time-consuming process, but it also significantly impacts quality. The program's interface is intuitive, and the interfaces of other software environments are very similar. Having thoroughly studied the interface and capabilities of one product, you will be able to confidently use other products in the photogrammetry category. After generating a dense point cloud, we can familiarize ourselves with it. Next, we need to create mesh polygons. In this case, from a point cloud, but other objects can be used. As always, we have standard and advanced settings. This construction occurs quite quickly because almost all computational operations have been performed previously. Note that our project uses 114 photographs. This is reflected in the status bar. After we aligned them, only one camera failed to link. This can be excluded from processing. Note that the digital terrain model will now be displayed. After this, we can create an orthophoto plan. As always, there are standard and advanced settings. We've successfully created an orthophoto plan. Let's take a look at the results. However, it's also worth paying attention to two tabs: Artificial Intelligence Settings and Export. We can export various types of objects and content to third-party programs. Let's note how we can view, enable, and disable the display of layers on various data. We can also sort our value using the height sliders. Here we see the minimum and maximum height. We can display values below the height specified by the data, sliders above the height, or within certain limits. Now, you can see the orthophoto plan laid out on your screens. We can also view a 3D reconstruction of our object. However, don't expect high quality from the 3D model just because our main goal was to create an orthophoto, not a 3D model. If we needed to obtain 3 models, we would have designed our flight mission differently. These photographs were all taken with the camera set at -90 degrees relative to the plane of our drone. When opening the settings, we can also increase or decrease the point sizes, camera sizes, and so on. There are also measurement tools, but these are only used for specific tasks. What you see on the screen now is the final version of the exported orthophoto plan we obtained.